Thank you, everybody. Great to see so many people participating. As Claire had mentioned, this is a two-part or two-day discussion. It will follow sort of a chronological path from the beginnings of understanding of broadband and all the way to actually operating and maintaining a broadband network. I get to do the first presentation, and it's Broadband 101, and it really will be the basics of broadband. Well, first, I'll do a quick introduction of NoaNet, since I'm the first NoaNet speaker. We are a not-for-profit wholesale telecommunications company. We believe in an open access philosophy, and open access, term number one of today's discussion will be talked about later, but it's an important distinction on the types of networks that public benefit networks subscribe to. It's a business practice, if you will, and I'll go into further detail, but essentially we're a not-for-profit wholesale open access telecommunications company who provides middle mile broadband services, term number two. And I'll go into middle mile later as well. We have roughly 3,800 miles of fiber that has been constructed in every county throughout the state. And through that, we host 911 services on our network. We host backhaul services for cell towers. We bring public safety and public health services to communities, educational bandwidth to communities and such throughout the state. But that's all I'm going to talk about around NoaNet, because we're not necessarily here to talk about ourselves. We're really here to talk about broadband. And what's a broadband discussion without talking about what broadband is and who it is that decides what broadband is. Okay, broadband, bandwidth. What term do you want to use? I don't care, but fundamentally we all talk about broadband and bandwidth somewhat in the same context. We as consumers of the internet, or we as consumers of data moving across infrastructure, we enjoy a reliable network, or we are frustrated with an unreliable network, or we enjoy a fast network, or we're frustrated with a slow network. Regardless, that is the broadband or the bandwidth in which your system is being exposed to, if you will. When we talk about broadband, we distinguish whether you have it or whether you don't have it based on a set of speeds. And these speeds have been determined by the FCC, and they have grown over the years. But essentially, today's speeds are 25 megabits per second coming down to you, the consumer of the bandwidth, and 3 megabits per second going up back into the internet, or back into the network. And these terms have grown over time. The previous FCC definition was 10/1, so 10 down, 1 up. And they grow over time based on the observation of the network's capabilities as they become more advanced and more infrastructure is deployed. In our state, Washington, we have a goal to achieve, and that would be 150 megabits per second and 150 megabits per second down to every home by 2028, and 1 gigabit per second down and 1 gigabit per second up to every business in our state by the year 2028. Your use of broadband, or your use of bandwidth, is going to be different than your neighbors. It's going to be different than the business down the street. So what you would consider suitable broadband is, and may be, a different definition than what the FCC uses, but nonetheless, the FCC's definition tends to be the benchmark towards dollars being delivered to areas in need, and also is the foundation of some terms, and I'll discuss it in my last slide: underserved and unserved. And so it gives us the ability to distinguish between those people who are adequately served, or considered adequately served, compared to those that are not, therefore those that will be considered in need. So how do these determinations come about? Well, broadband, the definition 25.3, has been determined by the FCC, and the FCC created a broadband map utilizing those definitions to chart where the areas were below that threshold and those areas that were above that threshold. The FCC made this determination by what I'll call an interview process of the service providers and their speed delivery capabilities within a census block or within a geographic area. And then that broadband availability was measured. That's your map on the left. And as you can see by the FCC, they recognize and acknowledge that there are a significant number of people that are still inadequately served. And there's a lot of them. And you probably, if you notice forest lands or farmlands or wheatland farms, you'll probably recognize that those areas are predominantly going to be less served than others. Now, here's a map on your right where Microsoft, and I think we all believe Microsoft is a reliable source, they've indicated through their tools that the broadband availability is much worse, right? 162 million people are absent of adequate broadband at the 25.3 levels. What did Microsoft do that was different than the FCC? Well, the Microsoft utilized their own speed test servers to make this determination. So what's the answer? What's the answer to the amount of volume of unserved and underserved people within our communities? It could be somewhere in between, or maybe we possibly need a third data set, and that third data set is an updated set of maps based on better statistic data gathering tools. Those kinds of tools, and we'll go in throughout this discussion, could include speed tests, could include community surveys, could include service provider interviews, and advertised speeds, could involve interpretation and analysis of existing infrastructure in census blocks to come up with what would be a more integrated map. Nonetheless, I think the point is, and the point is very clear, that broadband, as it's defined at 25.3, has huge gaps in our rural communities throughout the United States and also observed in Washington State. That problem gets exacerbated as the broadband speeds that you as a user increase, right? So when we're talking about the benchmark of 25.3, imagine if I changed that benchmark to 120. Suddenly, this blue map becomes very white very quickly. What is adequate broadband? How much broadband is enough? Why do you use broadband? And I think this slide gives us a feel for what the average residential consumer of broadband could look like. There was a day a home had a TV, but it was cable, and a home had a computer, but it was probably dial-up. And so therefore the broadband consumption, just because of the capabilities of the home, was low. But nowadays we have great tools and appliances that enable us to use broadband in a substantial amount. We have home security systems, we have Wi-Fi, we watch Netflix, we watch Hulu. I have about 6 Amazon Alexas in my house that yell at me all the time. All these things use broadband. And so the amount of broadband that I need and the amount of broadband, excuse me, the amount of broadband that you need could vary. And what about these 3 terms here on the right? What about affordability? What about accessibility? And what about reliability? The one thing that those maps don't show, and don't show very well, is the quality of our broadband. So you may have broadband may be accessible to you, but can you afford it, right? Can the citizens in your community afford it? And so are we measuring broadband availability in your area based on affordability? What about reliability? How is the broadband in your community when all of our kids are home from school because of COVID, and suddenly we're what we're calling saturating the network, and we can't do Zoom instruction with our teachers, right? How is the reliability? Point of the slide is our consumption varies across person to person to person, business to business to business, and then our user experience varies as well for such things as affordability, for such things as reliability. And when we start thinking about broadband and measuring broadband, we have to think a little more out of the box than just the speeds and feeds associated with the end user experience. Okay, let's start getting a little technical, and I promise I will stay a little technical because again, this is Broadband 101. This is Newton's Broadband for Dummies, or whatever that book was called. But let's start talking about two words, symmetrical and asymmetrical. So asymmetrical, simply put, tells you that if you've got a broadband connection to your home, where the download speed differs than the upload speed, you have an asymmetrical service. So you ask yourself, Chris, why do I have an asymmetrical service? Well, it gets complicated. But to make it really easy, it's because the way the networks are built. There are physics involved with infrastructure, and those physics say you can only do so much. And based on the equipment, the infrastructure, and the tools used, many networks are only able to send down to your home or down to your business a large amount of bandwidth. They just can't bring it back, right, to the same level. Now, that's fine if all you are doing is watching Netflix, because of course you're sitting there receiving Netflix, and that's fantastic. However, and as we all know with COVID, we sit behind a computer now, such as I'm doing on a Zoom call. And right now I'm sending you all my signal, right? And so I need a more symmetrical service, meaning that my upload speed is equivalent to my download speeds. Now, can an asymmetrical network become a symmetrical network? Sure. You can potentially change the equipment. You can potentially shorten the distances from point A to point B, but generally that transition is limited to your infrastructure and limited to your capital capabilities in order to transition. And as you can imagine, by just looking at those numbers, if you were to think about things logically, if my car can go 60, it's probably really hard to make my car suddenly go 200 without an engine change, right? And so you can imagine that an asymmetrical transition to a symmetrical transition is quite challenging, which really leads you to start thinking about things. Can we take old networks and make them new, or do we need to just take and build new networks? And that's a great question for you to keep in the back of your mind. Three other terms: backbone, middle mile, and last mile. You'll hear these terms a lot. You'll hear other terms similar in nature. You'll hear things like local loop. You'll hear things like distribution networks. You'll hear things like feeder cables. You'll hear all kinds of things, and you'll have to get that. You'll have to win that dictionary to see which one's which. But nonetheless, the predominant terms are backbone, middle mile, and last mile. Networks are a myriad of networks. And when you utilize bandwidth, or when you utilize broadband, you're using a myriad of different networks. Imagine if you're on the computer and you want to go to Amazon.com to buy something. Well, the first thing that you do is you access your last mile network. And your last mile network is your local service provider. That may be a large organization like Comcast, maybe a large organization like Lumen, or it may be your small local ISP or your cell phone that you utilize as the last mile. That's your immediate access to bandwidth. That's your immediate access to broadband. But that's not necessarily where you as an internet user want to stop, right? You need to get onto that middle mile network. And traditionally, it is another network. So as you're trying to go to Amazon.com, which may be hosted in San Jose, you have to get onto a middle mile network in order to leave your community. It may or may not be the same last mile network, such as in Comcast case, that may be, they may have that middle mile connectivity. But in many cases, it may be another network altogether. And that middle mile network is much like a NoaNet network in that we go from county to county, town to town, and we try to connect those different last mile networks together into one major network. Think of it as your local state highway system, if you will, these middle mile networks. Now, middle mile network is very useful and necessary, but of course it has to get you to San Jose. And so traditionally, either it connects to its own backbone network, which may go from one county to 3 counties later, or it may go all the way from Seattle, Washington down to San Jose in order to get that long range connectivity. Another term here that you might hear is long haul network, right? A long haul network would be a network that may go from Seattle to Salt Lake City to Florida, or it's an undersea cable that goes from, say, Everett, Washington to Tokyo. These kinds of long haul networks, backbone networks, really get you across the internet in an expeditious manner. And it's amazing how expeditious it is. But imagine once you get to that other location, you redissect this path, right? You get onto another middle mile network, and then eventually you get to a last mile network where you may be talking, if you're using a phone, you may be talking to your grandmother in Florida, who's to say. And believe it or not, you may be talking to your grandmother in San Jose and you're on a cell phone and she's on a cell phone, but the entire network between it, middle mile, backbone, what have you, could be on a fiber cable system and you have no way of knowing. What you do know is you've got a fantastic signal, or you live in an area where you don't, right? And we all know and have experienced that. These are important terms. And the reason they're important is because, well, one, education is fantastic, but two, when we start thinking about ways to build networks and ways to solve the digital divide, as I mentioned earlier, all three of these networks are necessary for the connectivity to occur in an affordable and a reliable manner. If we just had a robust last mile network that connected to nothing, guess what you're going to get? You're going to get nothing. And so it's important that we build infrastructure, last mile, middle mile, and backbone in areas in which they're absent.
We have a question from Drew. How does backhaul fit into those terms?
Backhaul and front haul are really terms associated with which way are you sending the signal based on your aggregation point. And so if you're a cellular company, your distinction of backhaul and front haul are really dependent on which way you're staring, if you will, at a macro tower. Traditionally, though, when we're trying to keep it simple, stupid, backhaul is the term used by your service provider to take the connectivity in the local area and haul it off to an internet point of presence so it can make its way to its final destination. Most internet service providers will buy internet or backhaul from another provider in order to connect their internet routed system to another network's internet routed system.
So it sounds like that might take place on the middle mile and the backbone?
Correct.
Backhaul?
Absolutely.
Okay. Yep. Great. That was helpful. Thank you.
Sure. So traditionally, there are two broadband technologies. This could be argued a million different ways, but there's wired and there's wireless. And wired technologies, if you go back, 50 years, wired technologies were relegated to telephone lines, and there were telephone lines up and down our streets, and people would utilize those telephone lines to do phone calls. And eventually, as time progressed, we were able to start utilizing those telephone lines for 56K dial-up modem, really doing broadband, if you will, over a phone call. We transitioned that into DSL, gave us faster speeds, but we're really utilizing that old copper twisted cable that has been on the pole line for quite some time. Luckily, the cable companies also came into play when it came into broadband, and they utilized their systems that provided you just TV. We were all watching Leave It to Beaver, and now we're able to get broadband on those coaxial systems that have been up there. So we're really being creative in our evolution of infrastructure, evolution of our technology on that infrastructure in order to keep up with the broadband consumption that I talked about in slide 3. However, there are so many situations where a copper solution, limited by physics, limited by the technology that we can develop, really pushes us into a fiber optic cable solution. Fiber optic cable is inexpensive to produce, yet is complicated to install, build, and maintain as the copper systems. However, what they do by building these networks is they give us the ability to increase capacity exponentially, and it gives us the ability to have infrastructure in the ground and on poles that up until today has been considered, and still today, has been considered future-proof because the equipment vendors continue to be able to deliver services. Claire, did I just lose internet there for a second?
You were fine for me.
Okay, perfect. So that's the first slide of wired technologies. Like I said, there's a copper or twisted pair component to it, copper, and then there's the fiber optic component to it. And what's always, I think, fun if you're going to be in broadband is to really understand how networks are built. And they're built through a myriad of different ways. Traditionally, we've put fiber and twisted pair and coaxial cable on poles, right? Poles, as we probably all know, are less expensive to do and provide us a quick and efficient way of bringing infrastructure to locations. However, many network operators believe underground wire deployments are more reliable. And from that, we start building systems either through plow trench, or a directional drill. And a plow is nothing more than a gigantic tractor that's got a big blade and it goes in the ground. And as it's digging up the dirt, it's sticking a conduit into the ground and putting fiber into that. Plow is a very useful and cost-effective way of building infrastructure in soft ground situations, more likely in farm fields, along state highways, along county roads. You won't necessarily see plow in town. You will see trenching, where you take a backhoe and dig a hole, kind of like what you see on the right, top right corner, excuse me, or in areas where you really can't break the surface, such as underneath a driveway, you may see directional drilling. And a drill, as that little red Tonka toy there in the center, just drills a pipe right through the dirt, pops it up on the other side, grabs a conduit and pulls that conduit right back through. Very expensive to do, but enables you to be less obtrusive to the environment or to the existing landscaping, concrete, what have you. Now in our days, we've started to see more and more micro trenching. You've probably heard about micro trenching. And the first thing that everybody says is, oh, micro trenching is fantastic. It's so cheap and so affordable. Okay, that's fine. But micro trenching is a complicated mechanism to build. And its purpose is to create a tiny little sliver in the ground that you put smaller pipes, smaller cable in, and therefore it's less cost effective because it's less disruptive. The problem with Washington State is our geographies are all over the map. We've got rocky conditions, we've got soft conditions, we've got cobble, we've got so many things that put us in a position where micro trenching is a challenge. And the reason I'm just sharing that is, as educated individuals, we need to recognize that any one of these construction methods or mechanisms are or may not be suitable for the location in which you're worried about. And let yourselves take advice from construction folks in the proper method to be utilized to build infrastructure in your area. Micro trench may not be the best solution. Heck, aerial may not be the best solution. We have things like squirrels, we have things like ice loading, all different kinds of things that come into play when it comes to wired network deployments. Here's some fun little pictures. If you want to talk broadband, you need to talk about infrastructure. We don't have broadband without infrastructure. It is not a chicken and an egg. You have to have infrastructure before you have broadband, plain and simple. And these are some of the fun little things associated with that. Handholds in the upper left-hand corner. There's also a handhole in the upper right-hand corner. These are, 30-inch by 30-inch boxes where fiber goes into, and fiber is all coiled up. And the fiber comes in on one side, goes out the other. What's different about the handhole on the left and the handhole on the right is the handhole on the right has a fiber cabinet. And there are so many situations where somebody says, I have fiber out my front door. True. But does it look like the item on the left? Does it look like the item on the right? Or can you not really see it all together? And the reason I shared that is because just because fiber is out your front door does not necessarily make it easily accessible. Fiber is a complicated infrastructure system. It's much like your highway system. And just because you have a highway doesn't mean you can drive on it, because you have an absence of an on-ramp, right? And in order to get on the highway, you need that on-ramp. In order to get on to the railroad tracks, you need a train stop, right? And so just having infrastructure in play does not necessarily mean we can use it, which is a great topic as my earlier slide where we talked about backbone, middle mile, and your local network, right? Your last mile network is really how we get services to the consumer. It isn't necessarily that long haul network. It takes all three networks to make the network work. Just some other pictures up there. You've got splice case on a pole with the cute little trees in the back. Those look like palm fronds. We probably should have used an evergreen or something to make it more local. And then the ONT on the left corner. ONT is an optical network terminal. It's really just a broadband box on the side of a house, and your home network would connect to it, and your service provider would be delivering your services to this ONT. There's other terms you might hear people talk about to describe an ONT, customer premise equipment, NID. I mean, there's all kinds of terms to describe this, but For all intents and purposes, it's a box on the side of your house and a cute little fiber cable coming out the bottom of it, kind of like a mouse's tail. All right, so we talked about wired. We talked about the basics of a wired background network. Let's talk a little bit about wireless. Wireless is complicated, and I probably could do a presentation on wireless for a long time. In fact, our afternoon session will go into wired technologies I previously spoke about and wireless technologies as well in more depth. And I'm going to keep it very high on purpose, high level on purpose, and not get into the weeds, because again, it's Broadband 101. But let's talk about wireless connections in three contexts: satellite, fixed wireless, and mobile wireless. And let me start with fixed wireless. And the way I like to conceptualize fixed wireless is that the connectivity over the air is occurring between two devices that don't move. And so you would have an access point that sits at your home, an access point that may sit on the pole outside of the street, out on the street. You may have an access point that sits on the roof of a building, and that is that's your receiving device that enables you to get the broadband to your location. But you're also going to have a fixed device sitting on some form of tower that enables the connectivity get from that location to your serving location. That's fixed. It can be licensed, it can be unlicensed, meaning that the spectrum is either paid for and you own it, licensed, or you don't pay for it and others within your general vicinity could be utilizing it as well. And there needs to be some coordination. Nonetheless, fixed wireless, and the way I like to think about it is you've got two systems and they don't move, as compared to satellite. Satellite, as we all know, is something floating around, the Earth in orbit, and that is not fixed, really. It's mobile, and it connects to a device down on the Earth that is probably fixed, right? And so you would have some kind of dish sitting on your house, whether you're using your traditional services like DirecTV or HughesNet, or you're utilizing something that's really new, state of the art, and that's low Earth orbit, or LEO, provided by organizations like Starlink. And if you haven't heard of Starlink lately, it's one of Elon Musk's great ambitious projects. It is intended to bring broadband, however you want to call broadband, to remote areas at a more cost-effective manner. And then lastly, the bottom one, mobile wireless. If you don't know what mobile wireless is, call me. And if you do call me, you're on your cell phone, so you know what it is. Another tool to think about mobile being your cell phone, that then that connection goes to a fixed location, which is probably a cell tower like you see in that bottom right-hand corner. So there's lots to talk about when it comes to wireless connectivity. There are many pros and many cons to wireless connectivity. Wireless can be considered more affordable. Wireless could be considered less reliable and slower speeds. Even with fiber, there are considerations you need to take into when deploying the appropriate infrastructure for the appropriate problem at the appropriate price. And that's a whole topic all unto itself. Cute little pictures here. That is a Christmas tree in the upper left-hand corner. That's supposed to be a cell tower. Much like the cell tower in the upper right-hand corner, this is where your mobile network connects to. This is where your fixed wireless network connects to. And then, of course, your satellite dish in the bottom right-hand corner, something that you would utilize with LEO services, right? Low Earth orbit, or your DirecTV or your dish services. All right, let's talk about 5G. So this will be the last wireless slide. Specifically to cell phone services. So we are in a world where G, which stands for generations, is moving. As you can imagine, there was a 3G before there was a 4G, and now we're all talking about 5G. What we have predominantly in most of our locations is a 4G LTE network. Really what we took was a 4G network owned by the cellular carriers and made it better. 4G is the standard, LTE is the improvement upon the standards. And most of us, if we've got 3 or 4 bars, 4G LTE works pretty well, and you probably can watch a YouTube video on your phone. 5G however, is the next standard, and it is the movement towards developing a system that is more robust from a broadband perspective, so we can move beyond our cell phones. Can you, and hopefully we can, utilize 5G systems to start to enjoy quality of life solutions such as broadband to the home over a 5G network? Truth of the matter is, the more options we have as a consumer, the better our broadband is going to be. So if I can get a 5G solution to my home, and I can get a wired solution to my home, and potentially a fixed wireless solution to my home, I've got better service. Yes, it might cost a little bit more, but if I need it and I'm a consumer, then I'm going to consume it, right? And I have the ability to look at that. What's great about 5G is not only are we utilizing it for our cell phones and potentially using it for business and residential services, but it will start enabling us to do things like smart cars, right? Autonomous vehicles are something that everybody talks about, and they will inevitably use this mesh of wireless networks and 5G networks in order to be productive. I'm gonna start speeding it up a little bit just because I just looked at the time and I'm already eating up a bunch of minutes. Couple more terms, private LTE. LTEs, you heard me say a few minutes ago, this is a term that would represent a mobile network that you would utilize to manage your own private organization. And you might, if you were a service provider, potentially use this private LTE system or network you've built to sell services on it as well. And then CBRS is another term that you will hear quite frequently. It is the buzzword for mobile connectivity right now. It utilizes the CBRS system that was traditionally reserved, that is now started to be opened up for private networks to procure and then utilize for a mobile wireless network. All right, more terms.
Get too far off that. The question has come up from Mac. How dependent is 5G on fiber versus cable? Or what kind of wired connection is happening with 5G?
Yeah, so think about them as complementary networks. And so 5G right now is a fantastic short-term solution in order for you to use your mobile device, cell phone, or for you to use some kind of appliance that maybe you have at your home that gives you great connectivity in your particular small region, your region being the area around where you're operating or working. That network traditionally will connect to a device that may sit on a pole, and that pole, utility pole, street light, what have you, may have fiber connectivity back to a macro cell tower in order to take all that aggregation of data, because you've got a lot of people using the 5G in that neighborhood, and getting it back to a more robust network connection, which may be a macro tower or a cell tower. That there also needs to get back to a more robust location, probably utilizing fiber in order to connect to what's called a MITSO, where all of these different systems are connecting. So 5G is, if you're utilizing 5G, you're not just on a 5G wireless network. You're only starting on that network, right? You essentially will transition into a fiber-fed system because your connectivity, you're not calling your neighbor. You're calling your grandmother, right? Or you're logging into Amazon.com in San Jose, and so you will be across fiber networks, and they complement each other.
Yeah, and it sounds like you really emphasized fiber because 5G is so data heavy. Theoretically, if it really gets deployed, that fiber is going to be needed.
Yeah, it's very data heavy, and as you start to aggregate multiple 5G signals, then you can't just rely on a gigabit connection. These networks are becoming 10 gigabit networks. They're becoming 100 gigabit networks. Heck, NoaNet is about to deploy a 400 gigabit network. I mean, the numbers are becoming astronomical because you saw as my third slide, we're consumers, right? We love to supersize our broadband.
Perfect. That was a great explanation. And we've also had someone ask about latency, which I see on this screen here. So you're getting to it.
Sure. Now let me hit latency right now. So latency is one of a few words, latency being probably the most commonly used. It is intended in layman's terms to describe how the quality of your broadband connection is based on your usage. And so latency, as the network starts to have to retransmit signals because of slowdown problems or congestion problems or what have you, the signal becomes less useful, right? And so a video signal experiencing latency might start to seize up, might start to shimmer a little bit, or heck, even your TV channels you're watching Netflix might just see latency issues as you start to see the TV signal pixelate. Is it a problem? Probably not. You'll live through it. But imagine if you were experiencing latency at a hospital and you were doing something that was life-saving involving broadband, and so suddenly latency becomes an extraordinary problem. What's interesting about today's networks is rarely do you have a network just to support people who use Netflix and then another network that's meant for 911 or public safety, right? They're the same network. And so if the network has high latency problems, then more than likely their user base is going to have a concern. And so wireless networks are known to have greater latency issues than say a copper network. A copper network's known to have bigger latency issues than, say, a fiber network. That doesn't make any of them worse than the other. What it means is you have to have the right network for the systems that you're trying to support. A high latency network is going to be an inferior product. Is it good enough to talk on the phone? Probably, right? But if that's all you want to do with it, then maybe you need to take into different considerations. Throttling and data caps, very similar words. Throttling is a tool used by internet providers to slow down your consumption of broadband in order to manage the amount of internet available to all the different homes. And so they throttle your service in order to keep everybody operating sort of at an equal playing field, versus prioritizing one customer's traffic over another. If your traffic is getting deprioritized, you are going to see having all kinds of connectivity problems. And so networks tend to get throttled in order to everybody maintain some usefulness of it, yet spread the available bandwidth across. The more robust your network is, the less throttling that's necessary, and therefore the more functional. Throttling is not necessarily a bad thing. It's a tool utilized by service providers to ensure the networks are adequately providing the service that they need. Perfect world, we don't need a throttle, right? We've got great infrastructure. It's all state of the art. It's no more than 2 days old, and the equipment's brand new, but that's not really how it works. Data caps, if you don't know what a data cap is, you were first exposed to it in the cellular world, where they said you can have 25 gig, right? And then the second you got to 25 gig, you were done. Data caps is a tool used by service providers to limit your usage because they don't have enough available bandwidth assets to support. And so they cap you. As these networks get bigger and more robust, data caps go away. But if you were to talk to me about unserved and underserved, if I'm a consumer of broadband and I have a data cap, I'm unserved in some form or fashion because I'm not getting the throughput that I need for the entire calendar month or whatever their windows are. Let me move into the term speed test. And I just want to talk speed tests really quick. It's a term that people love to use. We all want to talk about speed tests. We all want to get behind our computer. We want to do a speed test to see what our connection is. And then it comes back and it says, oh my goodness, I'm 76 megabits down and I'm 8 megabits up. And then you decide whether that's a good number or not, right? Well, a speed test is from your device across your own home network into your own home router into your service provider's local network that eventually goes to a speed test server somewhere else. So it then traverses a middle mile network. It may traverse a long haul network, and then that signal comes back to your home network, to your home router that might be 5 years old, to your laptop that might be 6 years old. And then suddenly you're upset because your throughput is 16 down, 3 up, right? Well, your speed test can only be good as the overall system. And so any break in that chain causes bad speed test results. The reason I share that is speed tests get a bad rap because people beat them up all day long, right? Saying, well, speed test is a bad tool to measure throughput because of all the things that Chris just got done describing. That's true. However, a speed test is a measurement of the user experience. And the user experience means that they're going to have a myriad of different ways they're going to access broadband. Sometimes I access broadband from my cell phone. Sometimes I access broadband from my iPad, sometimes from my computer. And sometimes I'm at work and I'm utilizing the largest computer you've ever seen. My speed test is a direct reflection of the quality of my bandwidth. Sure, it's flawed, but that doesn't mean it's a useless tool. All right, moving on. Dark fiber versus lit fiber. What's the difference? Dark fiber shouldn't even be a word. There's fiber and there is fiber. If you have fiber in the ground and it's connected to splice cases and it's connected to what's called patch panels and it goes from one building to another, it's fiber. It's nothing more than that until somebody comes along and puts electronics on it. The second those electronics are put on it, it becomes lit fiber, right? So fiber is just infrastructure. It's a wire and a conduit. It's a cable, it's glass, it's just stuff. It isn't lit until you put electronics on it, which means it's not broadband either, right? It's not bandwidth until you put electronics on it. And so when you think about dark fiber, think about it as infrastructure, right? It is the conduits in the ground. It's the fiber in the ground. It's the vaults, it's the splice cases. It's the fibers going up the poles. It's the fiber between the poles, right? It's just infrastructure. That's a big contrast from a lit network, a network where people are putting electronics on it. They're configuring the electronics. They're giving you a service that you can utilize. Simply put, that's the difference. There's even a third component to it, and that is the applications, right? We've all heard of things like Internet of Things and so forth. And so even once you light the fiber, what good is it unless you can utilize it in an effective manner, which is why you need a laptop, right? It's why you need a browser to browse the internet. It's why you need the app to use Netflix, right? And so lit fiber even transitions into a more robust system because now you're utilizing the over-the-top solutions to support it. So you kind of see the evolution of broadband as you start thinking about an infrastructure perspective. It's really not useful until you've got all the fun little tools and toys that you have on it. All right, moving on. And Claire, if I need to speed up, just give me the signal. 3 terms: fiber to the home, fiber to the premise, and fiber to the X, FTTH, FTTP, FTTX. These really mean that we're building a fiber network that's going to start from central location, and we're going to build fiber all the way to what we call the backer board. And the backer board is that location in your house or in your building where that cute little fiber cable coils up and connects to a device, right? So FTTH, FTTP, FTTX, those are all references to those kinds of terms. It's a fiber network, right? All right, next 2, gigabit passive optical network, or GPON, passive optical network, or active Ethernet optical network. Generally speaking, if you and your homies are sitting around talking technical and they want to know what kind of network you have, you very likely have a GPON network, or you have an active Ethernet network over optics. And this is wired, right? I'm not talking about wireless, but these are networks and these are terms you will probably hear. Active Ethernet is a set of electronics that network engineers utilize to provide broadband to a location. It's a different technology than GPON. GPON also can run Ethernet over it, not relevant to this particular topic. The point is people deploy one or the other, or they combine both. And those are decisions that you as a broadband manager would make as you build and deploy your network. Last 2 terms: CPE, customer premise equipment. That's really a device that the service provider installs at the home, at the business, that your internal network connects to. So your internal, if you're a homeowner, your router connects to that CPE. If you're in business, your switch, your router, what have you, connects into that CPE. So that's a term you'll hear quite often. And then of course, Wi-Fi, right? Wi-Fi is a standards-based wireless network solution meant for your local location. So in your house, in your business, maybe at a corner of a park, right? It's short distances that enables your cell phone to possibly work because you've got Wi-Fi enabled cell phones, allows your laptop to work. You can use it in the airport, so on and so forth. Wi-Fi is in version 6. You may not have a version 6 Wi-Fi router at your home. So your speed test is not going to look as good as mine because I do have one. Right? Another complications with the term speed test or with speed tests. All right, so what makes up a network? I talked about this a little bit earlier, but I want to restate it because I think it's important as we look to our state. We need 3 networks. We need the access network, and this is the network that's in your community. We need the middle mile network, and then we need the long haul network. And all of that is the puzzle that makes the cloud work. See how I tied that together? That was fantastic. These are three critical components. And in our state, if we're really going to solve the broadband problem, we have to champion access networks and get them built and constructed in every community in our state. We have to make sure we've got enough middle mile network connectivity to connect all of these towns and communities and cities together. And then we have to have enough infrastructure on or about the state and leaving the state in order to make this happen. And these are critical to our future. And what the future could look like is bringing more and more technology to our local communities. And we can do that by really creating the next level of infrastructure. Once we get past the infrastructure necessary for broadband, we can start looking at taking that broadband connectivity to the streets. And those streets will give us the smart city solutions that enable our future. We already know our urban counterparts are starting to drive EV cars. We already know our urban counterparts are leaning into autonomous vehicles. We already know our urban counterparts are utilizing smart city solutions to increase public safety, to establish Wi-Fi, to create communications for police, fire, and rescue. We're creating all these great different ways to manage transportation with bus systems and traffic light management. The more infrastructure we have in our communities, we will be able to do better things than just providing broadband to homes. We'll be able to bring broadband to curbs. And so suddenly you're utilizing broadband every aspect of your day. And quite frankly, you are, right? You're using electricity every aspect of your day. You turn on the lights the second you wake up, you turn off the lights the second you go to bed. I guarantee you that's the same with broadband, right? You're using broadband the second your eyeballs open, and you're using broadband until your eyeballs close. And then broadband's still working because it probably sets your alarm, because I know my alarm is Amazon Alexa. All right, open access. I promised I would talk about it. Open access is a term we're using a lot within our legislative group. We're using a lot in our public utility district group. We're using a lot in our port district groups as these organizations look to build networks. Open access is a philosophical approach to business that says if a public benefit network is going to be built, so NoaNet's a public benefit network, a port network is public benefit, a PUD network is public benefit. If you're going to build this network, then you are going to you're going to give that connectivity opportunity to an internet service provider, to a retail service provider, or to a carrier to at a non-discriminatory fashion in order for them to provide services to the end user. Why is that important? Well, it closes a much needed gap. An open access network or a broadband network very often is limited to infrastructure, right? We don't have infrastructure. And so what an open access public benefit network does is it closes that gap. It opens up an opportunity for a retail service provider or your local businessmen and women to provide innovative products to the consumers, both business and residential, that they can utilize. And an open access network says we're going to create a level playing field that allows competition to be provided. And we want it all, right? As humans, we want it all, right? We want great broadband, we want great competition, we want great customer service, and we want great pricing. And open access networks give us the ability to utilize a myriad of different opportunities and applications on a public invested network. Unserved and underserved. Those are terms you're going to hear a lot. And if you haven't, and I'm sure you already have, right? You've been talking about the digital divide. You've been talking about unserved. You've been talking about underserved. Who's underserved and unserved? Well, it's our neighbors who live in low population areas, and it's expensive to build to them, right? If I can build a network for $100 and connect to 20 customers because they're all close, my network's going to be profitable. But if to get to those same 20 customers, I got to build $1,000 worth of infrastructure, then it becomes quite challenging. And so in our state, we have so many unserved and underserved areas because we have so much of our state that's rural. I think really only 3 counties are considered urban, and even those counties, heck, King County, the whole eastern side of King County is is rural. And I know for a fact, many of those areas are unserved and underserved. Why? It's expensive. And back to my open access slide, what a great opportunity to solve that problem by creating public investment to overcome the infrastructure shortcomings while still providing connectivity through RSPs, ISPs, and carriers. What a fantastic opportunity. Unserved and underserved is going to continue to be a conundrum, right? As broadband speeds and the definitions change, unserved and underserved people are going to change with that definition. But then in addition to that problem, how are we going to identify who those people are? What a persistent problem, right? And so these are going to be very important things for us as community leaders to get our arms wrapped around when it comes to broadband. And if you remember my third or fourth slide, I think it was, I talked about affordability, accessibility, and reliability. That's all part of the unserved and underserved issue. Nonetheless,
I'm gonna let you know you have 2 minutes.
2 minutes, that's good because I think I'm on my last slide. Nonetheless, that's not doom and gloom. There are many organizations out there who have gone through what is broadband. They know what broadband is. They potentially have an opportunity to solve the problem, and now they're going after it and trying to solve that problem. And by your attendance here, you probably are recognizing that there's a problem in your area. You need to know more about it. And we're here to help you learn more and get you the tools that you need. All right, so my 2 minutes is up, Claire.
All right, I have 2 questions we want to pose before we let you go. Can you give your best quick explanation of dark versus lit fiber one more time?
Sure. Dark fiber, don't think about it as dark. Think about it as a fiber cable that sits in the ground or sits on a pole, and it goes from point A to point B. And the fiber on each end connects to something. It goes into a building, onto a wall, goes into a vault or a splice case or whatever, and connects. And it's just fiber, and it doesn't do a darn thing. A dark fiber network, if you will, is infrastructure that you would provide to others to utilize. It does nothing until it's lit. The second it's lit, it's useful. So what makes it lit? Somebody on one end of the fiber connects a device that costs money to another device on the other end that also costs money. And as much as we would love to go to Home Depot and buy a $100 device to connect them, they don't cost $100. These devices that turn them into lit are quite expensive because they go long distances and are high capacity systems. And so lit is almost its own network onto itself, and it takes a whole nother group of engineers to operate and maintain than it does just the dark fiber. And the other nuances between the two is there's different business approaches with dark fiber and lit fiber as well. And that's probably another conversation that might take an hour unto itself. So I won't kill you with boredom explaining it now.
Perfect. Well, there are a couple other great questions that unfortunately we ran out of time for. I'm gonna keep those down here and hopefully we'll get to them later if we have time. But Chris, thank you so much. That was really interesting. I always enjoy hearing, back to basics. I always pick up something new. So I really appreciate it. Thank you so much. And great questions, everyone. Keep them coming.